Hello there, it's Mrs. Tremblay. It's time for lesson 2.4, solving one-step addition and subtraction equations. Now I know that you have seen some equations before and you have done guess and check with finding their solutions. Today we're going to talk about a systematic way that will work every single time that doesn't involve guessing. Because sometimes guessing can be fun, like you're at a carnival and they have those little games where they guess your age or guess your weight or all that stuff. But in solving equations, just knowing how to guess can take a long time. And when things take a long time and you have like 25 problems staring at you, it's no fun. So I want to show you a way to solve one-step addition and subtraction equations, and we're just going to keep building on that throughout this section. We'll actually revisit these again in chapter 10, but for now we're starting with the baby bear equations, I call them. Alright. So they're called one-step addition and subtraction equations because it just takes one step to solve them, and they're going to have an addition sign or subtraction sign in them. The goal to solving any equation is to figure out what the value of the variable is that makes the equation true. In order to find the value of the variable, you have to isolate it, and isolate is just a fancy word for get it by itself. The additive inverse property allows you to do this with addition equations. And remember, we learned about the additive inverse property in chapter 1. It says when you add opposites, you get 0, and getting 0 allows you to cancel some things out, which will allow you to get some other things by itself. So we'll start out using a nice little model for this, because I find that that's helpful to have a picture of it in your mind. I have a little balanced scale here, and that's kind of how I want you to view all equations. Here's my word art balanced scale. This is the best I could do. So here's a scale, here's one side, here's the other, and right now they're balanced, right? We're saying that this side is equal to this side. So when you see y minus 3 equals negative 4, that means that these are balanced, that whatever's over here equals the same thing as that. They weigh the same amount. So what I'd like us to do first is to put this equation onto the mat so that we have this visual picture. But before you put that equation onto the mat, I need you to do me a favor and change the signs, because I can't stand looking at y minus 3 when I know it should really be y plus negative 3, right? Then we're less likely to confuse the values here. So, yeah, your step 1 is still going to be to rewrite subtraction as addition whenever you see it. So here's my equal sign, and here's my equal sign. We're saying that this y plus negative 3 equals negative 4. That means I want to put y plus negative 3 on this side and negative 4 on this side. And these are just like our algebra block mats in class. We have a positive side of the mat and a negative side of the mat. Positive side of the mat, negative side of the mat. If I were to just put the expression y plus negative 3 on this side of the mat, and you can draw these pictures. If you have yellow and green marker or crayon, you could use that too. I'm going to use some markers that match it. And if you don't, it's okay. You can just use pencil. But y plus negative 3, to show that on this side of the mat, y's were those long yellow rectangles, right? And it's positive. So I have y, just one of them, plus negative 3. So on this side, to show negative 3, I would put 3 down here. So right here, this shows y plus negative 3. It's all on one side of the equal sign. And that's supposed to equal negative 4, right? Here's my equal sign. Negative 4 is on the other side. So on this side of the mat, I just want to show 4 negatives. All right. So that represents that equation, right? Now, our job is to isolate the variable. That means that I want this y all by itself on this side. So tell me, we talked about the additive inverse property being helpful. If I'm on this side of the mat and I want 3 negatives to go away, what can you combine with 3 negatives to cancel them out? 3 positives, right? So if I am on this balanced scale and I want to cancel these 3 negatives out, I can add 3 positive blocks to this side of the mat. And now when I simplify this, those 6 blocks would come off, right? Because 3 negatives and 3 positives cancel out. But the thing is, you know how you just made this side heavier by 3? That creates an unbalanced equation. So if you make this side heavier by 3, you need to do the same thing to this side to keep them balanced. That's what equations are all about. So whatever you do to one side to get the variable alone, because that will get the variable alone, those will cancel each other out, additive inverse, but I need to do that to this side as well. So again, we added 3 positive blocks to this side. That means we need to add 3 positive blocks to that side. Now at this point, I have y by itself, and in order to figure out what y equals, I just need to combine these 3 positives and the 4 negatives. And you learned before that when you add opposites, you get 0. So this -1 and this +1 will cancel out. And I'm just making all my 0 pairs like we did before. And when you have no 0 pairs left, that means you have your answer. So I see I have 1 block left on the negative side. That means my answer is -1. So kind of recapping what we just did here. The first thing that we did to isolate this y was we added 3 blocks to each side, right? So look at this as, here's one side, here's the other side. We had to add 3 blocks to this side in order to get y by itself. That's what happened, right? When you take y plus -3 plus +3, when you combine like terms, these constants go together. -3 plus 3 is 0, and y is left alone. But we also had to add 3 blocks to this side, because whatever you do to one side, you have to do to the other. And we said we were left with -1, right? Isn't -4 plus 3 -1? Yes. So y equals -1. All right, we're not going to do every single one with blocks, I promise you. But this really helps you understand why you're doing what you're doing. All right, take a look at this next one. This time I put the y on the other side. That's okay. It's not a big deal. I want to start off putting this equation up there, so I'm going to draw my line here. There isn't any subtraction. And I see that on this side of the balanced scale, I have -5. So I'm going to put my -5 over here. And I'm going to put my positive and negative signs in there. All right, and then that's equal to y plus 2. So y plus 2, those are both positive. Here's my y, and there's my 2. I'm going to put them all on the positive side of the map because they're both positive. Okay, your job is to isolate the variable, right? That means I want this y by itself. It's okay that it's on the right side. It doesn't have to be on the left. Okay, it's okay where it's at. If I want it by itself on this side, I need to get rid of those 2 positive blocks, don't I? How do you get rid of 2 positive blocks? Well, if you combine 2 positive blocks with 2 negative blocks, that'll cancel them out, right? So by adding 2 negative blocks to this side, you were able to get y by itself, right? But the thing is, when you added 2 negatives to this side, this became unbalanced. I need to put 2 negatives on this side as well, because whatever you do to one side, you need to do the same thing to the other. So I'm going to add 2 negatives to that side as well. And what's left? They're all negative. So 1, 2, 3, 4, 5, 6, 7 negatives are left. And -5 plus -2 is -7. Y is by itself, so we're done, and y equals -7. If you have to write it like this at the end, go ahead, but I don't care if the y is on the right. It's still solved. It's all good. Okay, one more with the blocks. I have 10 plus y equals -5. So this time, the y comes second. That's okay. It's not a big deal. When I say 10 plus y, that means I have 10 positive green blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we also have a positive y. So that's all on one side. On the other side, we have -5. So I'm going to put 5 blocks down here. All right, again, your job is to go ahead and get this y by itself on whatever side it's on. In order to get this y all by itself, I need to cancel out those 10 positive blocks. We cancel out those 10 positive blocks by combining them with 10 negative blocks, right? So these 10 positives and those 10 negatives, when combined, leave y by itself. So again, what we just did was we added -10 blocks to this side of the equation. And when you did that, the 10 and the -10 canceled out. You were left with y. But if you're going to add 10 negatives to this side, you better add 10 to this side as well. So whatever you did to that side, we have to do to this side as well. And they're all on the negative side. When you take -10 plus -5, you get -15. So y equals -15. Now I'm hoping that you're seeing through all of this so that we don't draw pictures every single time. But basically, wherever y was at, whatever number was being added to y, didn't we just add the opposite of it to both sides and simplified? That's all you have to do to solve a one-step addition and subtraction equation. You look at wherever the variable is at, and whatever number is being added to the variable, you add the opposite of that. And you have to do it to both sides of the equation because equations need to stay balanced. So let's try some without the blocks. Here we go. So there's a lot of words up here. These are vocabulary words that you have to know that you've already been exposed to at the beginning of this unit. But two equations are equivalent equations if they have the same solutions. Adding the same number to both sides of an equation, and that's the addition property of equality, or subtracting the same number from both sides of an equation, the subtraction property of equality, makes an equivalent equation. So all of this up here just basically describes what we're doing. We're adding the same number to both sides of the equation, and we're allowed to do that because of those properties. We're not changing the value of the equation, we're just allowing us to isolate the variable. So our steps, we are going to change subtraction to addition by adding the opposite. You get the variable alone or isolate it by adding the opposite of the number being added to the variable. So only the number that's being added to the variable. The other one you just leave alone. Then we can actually check every single answer. That's what's great about solving equations. You can check every single solution. So when you take a test on this stuff, you will know if you got 100% right off the bat because you can check them all. Alright, so I ask you to solve each equation here. The first thing I'd like you to do is look for a subtraction. And with this first example, I don't see any subtraction. I see a -10, but that's not subtraction. I always draw a line down from the equal sign to show one side being separated from the other, so I know that whatever I do to one side, I do to the other. And that's a hint to you that you should do that too. So draw your line down the center. Here is my x. I want to get my x alone. That sounds very creeper status-like. Sorry. You want to get x alone too, so there, you're a creeper too. Okay, so x plus 4 equals -10. I want x by itself. I have this 4 that's being added to x. How do I cancel out 4 that's being added? I add -4. Because isn't 4 plus -4 0? So 4 plus -4 is 0. X plus 0, yeah, it's x. So you got x alone. But right now it's not balanced because you added -4 to this side. You need to also add -4 to this side. -10 plus -4 is -14. So x is by itself, and this, according to this equation, it says that x equals -14. To check to make sure that it's right, and this is step 3 to substitute it back in, if we're saying that x is -14, then when you take -14 plus 4, you should get -10. So all we're doing is we're replacing x. We're substituting, just like we did in chapter 1. We're replacing x with what we said x is and making sure that it's true. And -14 plus 4 is -10, and -10 equals -10, so we know that we're right. X does equal -14. That's how easy it is to check your equations. All right, next one, I'm going to draw my line down from the center. Here's my y. I usually circle the variable so I know that's what I want to stay put. I want to solve for y. Right now, a -5 is being added to the y. How do you cancel out a -5 that's being added? With a +5, right? Because -5 plus 5 is 0. And 0 plus y is y. Now, if you add 5 to this side, you definitely need to add 5 to that side as well. And -18 plus 5 is -13. So y equals -13. To make sure that we are right, I'm going to go back to my original equation here. I'm going to put -13 in for the y. So -5 plus -13 should equal -18. So again, this y became -13. I just rewrote the same thing. Is -5 plus -13 -18? Yes, it is. So we know that we're right. Next equation here. Oh, I see some subtraction, so I'm going to keep change that. N minus 3 becomes n plus -3. I'm going to draw my line to separate one side from the other. I want the n by itself. That means to get rid of this, I need to get rid of this -3 because it's on the same side the n is on, and n wants to be alone. It's okay that it's on the right. To cancel out this -3 that's being added, I just need to add a +3. -3 plus +3 is 0, so we got n by itself. If you add 3 to this side, you've just made this side heavier by 3. I need to make this side heavier by 3 as well. Whatever you do to one side, do to the other. Negative 13 plus 3 is negative 10. N's by itself, n is equal to negative 10. To check to make sure that this is right, again, all you're doing is replacing this n with what you got for n. So negative 13 should be equal to negative 10 plus negative 3. Yeah, negative 10 plus negative 3 is negative 13. Negative 13 equals negative 13. We know that it's right. All right, next one, draw your line. Here's P. I want to get P alone. I know that sounds so funny, doesn't it? Right now, negative 25 is being added to P. To cancel out that negative 25 so that P can be alone, I'm going to add 25 because a negative 25 plus a positive 25 are gone. So there, P is alone. Since you added 25 to this side, we're going to add 25 to this side, and 0 plus 25, yes, it's 25. So 25 equals P. Did you know that P was worth 25? I had no idea. To check it, I'm going to plug it back in. 0 should equal negative 25 plus P, and we said that P was 25. Does negative 25 plus 25 equal 0? You betcha. So we know that P does equal 25. We are correct. All right, now I have, of course, one with decimals so that you understand it's the same kind of rules applying here. So draw your line. There isn't subtraction. I don't have to worry about it. Here's H. That's the variable. That's what I want by itself. Negative 8.2 is being added to H right now. And we learned that with addition equations, you just need to add the opposite of what's being added. The opposite of 8.2, or negative 8.2 is a positive 8.2. When you add negative 8.2 and positive 8.2, that equals 0, because those are like terms. H is not. H is still left. Whatever you do to one side, you have to do to the other. So you're left with negative 1 plus 8.2. When you take negative 1 plus 8.2, you have to subtract the digits and take the sign of the greater. So 8.2 minus 1 is 7.2. And it's going to be positive because you have more positives than negatives. You would check this the same exact way. I want to make sure that negative 8.2 plus 7.2 equals negative 1. Does negative 8.2 plus 7.2 give you negative 1? Yeah. And if you didn't know, you could plug that in your calculator and check it out. Or you could write it out the long way and check it out. But negative 1 is what it equals. So that means that H equals 7.2 is correct. All right, last one like this, then we'll get into some word problems, yay. Z plus 3/2 equals 1/2. Just because there's a fraction here doesn't change this. This is an addition equation here. I'm going to draw my line. I want to cancel out 3/2, right? Because that's what's being added to the Z. To cancel out a number that's being added, you add its opposite. The opposite of 3/2 isn't 2/3. I'm not asking you for reciprocals. We're just given opposite signs. So I'm going to add negative 3/2. Because 3/2 plus negative 3/2 is 0. Z's alone. Now I need to take 1/2 plus negative 3/2. And I already have a like denominator, so I'm going to bring that down. 1 plus negative 3 is negative 2. That can be simplified, right? Negative 2 divided by 2 is negative 1. So Z equals negative 1. I would check this the same way. You just take negative 1 plus 3/2 and see if that's equal to 1/2. And we just said negative 1 is the same as negative 2 over 2, right? Well, negative 2 plus 3 is 1. Bring over your 2, and 1/2 does equal 1/2. So we know that that's right. Okay, last page of this. I want you to be able to write equations as well. So let's practice that. Writing and solving one-step addition and subtraction equations. Your keywords here, and I know that you have seen these keywords before. It never hurts to remind you of them, though. When you're dealing with addition, you're going to see words like sum, more than, added to, increased by. The keywords for subtraction are difference, less than, decreased by, or take away, maybe you'll see. So what I'd like you to be able to do is write an equation for each verbal situation and then solve it. So there's a few examples here. Let's knock it out. It says here, the sum of negative 12 and a number y is 8. Okay, so first off, I see the word sum. Sum means addition. I want the sum of what? The sum of negative 12 and a number y. So to show the sum of negative 12 and y, that just means negative 12 plus y. Wherever you see the word is, that means equals, right? And that is 8. You've got your one-step equation. All right, so right now let's just write that down. Maybe we'll come back and solve it. Maybe I'll have you do it for class tomorrow. I'll decide at the end. Okay, next one. It says negative 4 is. Well, right there I see the word is. I know that means equal sign, right? And it says negative 4 is. So negative 4 equals. And this says 10 more than x. More than means addition, right? So 10 more than x. Now, when you see more than, and it's 10 more than x, the words more than and less than, you kind of need to reverse the order here. Because if I'm saying 10 more than x, that means I have 10 being added to the x. This shows 10 more than x. So with addition, the order is not really going to matter, but with subtraction it will. So that's the best way to write it, and we'll just get into the habit of doing that now. So this equation will represent this situation. Negative 4 is, put my equal sign, 10 more than x. More than means addition. And if it's 10 more than x, the x needs to come, 10 more than x means the 10 needs to be added to the x. All right, next, it says the difference between a number c and negative 6 is 14. So here I see difference between. That word difference means subtract. I want the difference between c and negative 6. So to show the difference between, I'm going to take c minus, and I am going to use parentheses so that I don't get these negative signs confused. Don't switch the order here. This isn't a less than, it's the difference between. And I need to have the order as it's written, because with subtraction, order does matter. There's my is for my equal sign, 14. So there's my equation. All right, last one, it says 6 less than a number p is negative 5. So I have 6 less than. When you see less than, that means subtraction, and it's 6 less than p is negative 5. To show 6 less than p, if it's 6 less than p, this actually means p minus 6. Because 6 is less than the p, that means I need to start with p. Order matters. So when you see less than, more than, you're basically switching the order of these. And is means equals negative 5. All right. Now, what you would need to do next is solve those. So let's go through. I think we've got a couple minutes. Let's go through and quickly solve these. I won't overthink them. So coming back to this equation, I'm going to draw my line. I want y by itself. To get rid of negative 12, I'm going to add positive 12 to each side. Y is alone. 8 plus 12 is 20. Is negative 12 plus 28? Yep, so we're right. Look at the next one. We'll draw our line. Here's the x. I need to get rid of this 10 that's being added, so I'm going to add a negative 10. That means that x is by itself on this side of the equation. I just wanted to get x alone. It doesn't matter what side. And a negative 4 plus a negative 10 is negative 14. Is negative 14 plus 10 negative 4? Yep. All right, here I have a subtraction equation. And yes, I do want you to keep change. So this is what it would become. C minus negative 6 would mean C plus positive 6. Draw my line. I want this C by itself. 6 is being added. So add a negative 6 to each side. Those are gone. C is alone. 14 plus negative 6, positive 8. And is 8 plus 6 14? Yes! See how easy it is to check these? All right, last equation, it's subtraction, so I do want to keep change before I begin. So this would become p plus negative 6 equals negative 5. Draw your line. We want p by itself. Currently a negative 6 is being added to it. To get rid of that negative 6, I would add 6. I'm going to do that to both sides. Those are gone. P is alone. Negative 5 plus 6 is 1. And is 1 minus 6 negative 5? Or 1 plus negative 6? Negative 5? Yes, it is. We are done. See you tomorrow.